define an algebraic expression. We did it yesterday. So tell me, what is an algebraic expression? If we did it yesterday, you should be able to answer that question. Everybody's hand should be up. Jillian, what's an algebraic expression?
An algebraic expression doesn't have an equal sign, must have a variable, and have a symbol.
Okay. It's a mathematical sentence. It's a math sentence without equal sign, and it must have variables, at least one variable. Okay? It must have a variable. What do we mean when we use the statement terms? What are the terms in a math sentence? What are we talking about there? Kaden?
The letters or the variables.
Okay, terms could be variables. Okay,
Two things that are alike.
terms. Alice?
Well, it's like every section between the next sign is a term.
Okay, so it's the parts of a math sentence separated by operations. Okay. And if I could, but there, I wanted to get some space. Okay, for example, if we said, I don't remember what that one was, but 3x plus 4 minus x plus 1, I don't know. All right, if you notice, this is a term, this is a term, this is a term, and this is a term, okay? So in that mathematical sentence, there are 4 terms. And what is separating them is the operation symbols. The 3x combined like that is some number. And it would be a very specific number. But we don't say, well, I have 3 as a term and x as a term. They're combined. They're together. Okay? That's like a set of twins or something. I don't know. They're together. They can't be separated. Okay? Identical twins before they're born, they're combined in one egg sac, one sac. Okay? So they're identical, and you can't separate them until they're born. All right. Well, these two are twins. They cannot be separated until you determine what they are exactly. Okay? Can't separate them. I don't know. It just came to me. I don't know. So you have 4 terms.
Get on your feet.
That's exactly what it is. Okay? All right. And then the next question is specifically. Go. There, I got it. Then we're talking about, we want to know more about what are like terms. Okay? what are like terms? Whoops, that's too far. I'm having trouble with this today. Okay, how would we define the like terms? What do you think, Wesley?
Are they terms that are the same?
If you use the example we have there, what would you say would be the like terms? Trenton? 3x and what? I have two sets of like terms up there. But what do you think that they would be? What do you think, Sophia? 3x and negative x. Good. So variables to the same power they are like terms. And constants, which are numbers that don't have anything else going on. They're just, like the 4 is always going to be the 4 because it doesn't have anything else attached to it. Okay? So constants are also like terms. Okay? And I should say the same variables to the same power. Okay? If I have, I'll show you, I'll explain this to you with an example here in just a second. So if we go with our example up there. Okay, so we're going to go back to the example. We've got our 3x plus 4 minus x plus 1. Now earlier we said always change subtraction to add opposite. So I'm going to go ahead and do that. Now, my terms, my like terms here are my 3x and my negative x. So I can combine those two. And we said that was 4x. Or, we said that's what you would do. We said that is 2x, right? Okay. And then the constants, the 4 plus 1, are my other like terms. And so I got my plus 5. Okay? And that's how I simplify it. But I have to know my like terms. So if I was just going to list my like terms, I'd have 3x and the opposite of x, and then I have 4 and 1. Okay? If I up here was going to list the terms, so if I'm going to list my terms, I would say 3x, 4, now negative x, and 1. Because again, we had to add opposite there. See the lists and the way you would do it. Because I think you're going to have some of that where it's going to ask you to list the terms. Okay? So far, so good. Okay, let's see what we can do with this now. Here's the question. How many terms are in this statement? How many terms are in the statement 3x plus 12 plus x squared minus 5 plus x? And I'm going to go in and do what we said. Change it to add opposite. How many terms do I have? Ben, how many terms do I have?
5.
Ben says 5 terms. Do you agree with him? 1, 2, 3, 4, 5. Good. Now the next question is identify those terms. So in other words, you're going to list the terms. Somebody help me list the terms. John?
3x,
Uh-huh.
12, x squared by 2,
Mhm.
negative -5 and x.
Good. Excellent. Excellent. Now, I'm going to add a piece to this because it's not here. I want you to combine the like terms. Or I guess instead of doing that, let's just list them. Let's make sure you know how to list these. List the like terms. Somebody help me with that. Caitlin, will you help me with that?
So the like terms are 3x, x squared, x, and another set of like terms.
Okay, now I'm going to stop you for a minute. By definition, what did we say about like terms when we were talking about variables?
3x and x.
3x and x, okay.
And then the 12 and 5 are like terms.
Good. Why is the x squared not a like term to 3x and x? Why is it not a like term? Why not? Riley, why not? Why is x squared not a like term to 3x and x? What's it got that the other two don't? What does it have, Matthew? It has an exponent. And its exponent is different than the exponent you do not see here. Because x has an exponent right here. And if I was to give the exponent for this one, which you don't see it, it would be a 1. It's x to the first power. Okay, it's not 0, because there's 1x there. But that's one of those understood things that we don't show. Okay? You don't see this guy. You just know he's there. Okay? X squared is not a part of that. It doesn't have another one. Okay? So it has to be by itself. All right? It is not, does not have a like term. Do I want to do that? It's not really an exit ticket, but let's see what we can do with this one. Let's see what it says. It says, which of the following expressions will simplify down to 3x plus 4? It needs to go down to 3x plus 4. Is it going to be A, B, or C? Which one of them is going to simplify down to be 3x plus 4? Do you know already, Jillian?
No, but there's a D to it.
There's a D to it? Okay.
And it can be multiple. And it is. Following expressions.
Okay, we're getting down to 3x plus 4. Which one of those is going to simplify down? And in order to do that, you're going to have to do some combining of like terms to find out. So everybody should be doing. Wasn't trying to scare you. Yeah, you've got to do the math here, or you're not going to know it. Yes. Do it on your paper. What can I combine in A? What's my like terms here? Does 3x have a like term to it? No, so it's by itself. This one and this one are like terms. Do you agree?
Yes.
Okay. So if I'm combining them, I'm adding them together. Negative 6 plus 2. What do I get, ladies and gentlemen? Negative 4. Well, that's not it. B says distributive property, doesn't it? So before I can start combining like terms, I've got to get rid of the distributive property, right? I have to simplify that first. And so when I do that, I'm saying 3 times x, or 3x. Do I say plus 4? No. Why not? Why would that be wrong? And I see that done all the time. But why is it wrong, Aaron?
Because if you multiply 3 times like 4, it would be 12.
Good. You have to multiply the 3 times 4, which is 12, to distribute it. Okay, is that 3x plus 4?
No.
Nope. What about C? Do I have some well, first of all, I've got a subtraction statement, right? Change subtraction to a add opposite. Okay, I got that done. Now, like terms. I have 2x and I have x. That is 3x plus, now I have 8 and I have a negative 2. And what is 8 plus negative 2? 6. Doesn't work. That means it should probably be D. So, but I'm not going to make the guess, because what if the thing's wrong? What if the answer machine or page was wrong? What if there was a typo? So, I have negative 5x and 8x. When you combine those, what do you get? 3x plus 4, because that's the only thing left. So D is my correct answer. Now, why do I go in and circle up things like I did on C and put different symbols on the others? Why would I do that, do you think? Michaela, why do you think I do that?
Because that helps categorize the different like terms.
It does help categorize it. These are very small algebraic expressions. I have 8th graders right now that are doing and maybe, and it may even be like this.
I'm scared.
They're doing things like that and having to simplify it. Well, you've got to know what you can combine. Y squared divided by y squared, they're gone. And I've got a W here and I've got a W there, that's gone. But now I've got x to the 5th and x to the 5th, which is actually x to the 25th. Which would make it x to the 24th, because I can take one of these out of here and say, well, there's only 4 of those. And that's not going to work. Nope, that won't work for me. Sorry, I can't do that. You're right, I cannot do that. I would have to simplify that first. Okay? I still haven't simplified that all the way down. But do you see why I do this then? I've got to do something that's going to organize it in a way that I know that I have dealt with every term in the expression. Okay? And so I'm trying to teach that to you now. All right? There's your assignment. Only you do not have this, because we already did this one. So Math Journal, page 46, which is your practice. And then textbook 85, numbers 30 to 32.
Which notes again?